So far, we have solved quadratic equations by factoring. We've solved by graphing. And what we found out is when we graph, sometimes it's not always completely accurate. We'll have to make estimates. And we can't always factor every single quadratic. So both those methods aren't perfect. Another way we can solve quadratic equations is by what we call completing the square. And yes, completing the square sounds like it should be easy. And if you get the concept, it does end up becoming pretty easy. But if you are not familiar with your perfect square trinomials, like we did last chapter, then it could be a little bit of a struggle. So first of all, I have a perfect square trinomial up here. X squared plus 10x plus 25. And I can check to see how that works. Remember, I take the square root of the x squared, which is x, the square root of the last term, which is 5. I multiply those and I double them to get a 10x, so I know it's a perfect square trinomial. Right? In the end, this breaks up into x plus 5 squared, right? The square root of the first term, the square root of the second term. And so we're going to use this. And the reason why we want to complete the square, basically we're going to add this 25 onto our x squared plus 10x. And this will make sense in a sec and how this works. So let's look at this. When I get that x plus 5 squared, and it's equal to something, this is why we want to be able to get it to a perfect square trinomial. If I think in the past, if I had x squared equals a perfect square, for example, to solve for x, we always do the inverse of what's being done. The inverse of squaring is square rooting. Okay? So x would equal, most people want to say just 7. But if I think about this, originally it said some number squared gives me 49. Well, 7 squared gives me 49. But so does negative 7 squared. So x equals plus or minus 7. It equals a positive 7 and a negative 7. So the same thing goes for my problem up top here. Nope, not very good at my circle erase here. So looking up top, I want to get that x by itself. Well, the whole side is being squared. So what I want to do to get rid of that square is to square root, right? I can't minus a 5 yet because I got those parentheses blocking it. And whatever I do to one side, I do to the other. Well, the square root cancels with my square, so I'm left with x plus 5 equals, so here's the key, plus or minus 7, a positive and a negative 7. Okay, because that's going to give me two answers in the end. Now when I subtract 5 from both sides, I have to do 7 minus 5. And I also have to do negative 7 minus 5. So I'm going to get two answers. I'll get a 2, and I'm going to get a negative 12. So x equals 2 and negative 12 in this case. And so that's the nice part. Because if I'm originally given my x squared plus 10x plus 25 equals 49, I can't just solve that. I'd have to factor. And to factor, I get that x plus 5 squared. Okay? But it's not always going to work out that nicely. I'm not always going to have a perfect square trinomial here that works out. So we want to complete the square. Well, to complete a square, any quadratic in the form ax plus bx. So basically, there's no c term. There's no constant at the end. I can make that into a perfect square. So let's look back at our original example we had. Let's say this 25 didn't exist. That 25 is not there. I just have an ax squared plus 10x. I can come up with that 25. I can make this a perfect square. And to do that, what we do is, I have this here. What we do is we take half of b, and then we square that. And we end up calling that term c, and we add that at the end of our x squared plus bx. So let's try that up here. So if I look, my b term is 10, so I'm going to take half of 10, which is 5, and then I square that to get 25. And I just add that on to what I just had. So there you go. I just made it into a perfect square trinomial. Because now that eventually would break down into x plus 5 squared, which will help us when we want to solve. So first off, let's just start by solving for to make it a perfect square trinomial. We want to find that value of c that's going to make it a perfect square trinomial. So we just follow that rule. Take half of b and square it. That's all you got to do. So look, my b term is a negative 12. I take half of negative 12 to give me negative 6. Square that to give me 36, right? Negative 6 times negative 6. So my c term is 36. So I'm okay if you just want to say 36, that's good. If you want to rewrite the whole polynomial, your whole quadratic, I'm okay with that as well. Either way, okay? So 36 would be what would be added on. Same thing, even if I don't have a whole number to work with, if it doesn't divide evenly. In my next case, I have 13 as my b term, so I take half of b. Instead of making it a decimal, let's just keep it as a fraction. I can square this easily, because we take half of b and then we square it. So I could just square that. Well, remember I can just distribute my squares, so 169, right? 13 times 13, and 2 squared is 4. So there you go. That's what gets added on at the end. So remember, I can just say that's my c term, or I can actually rewrite my whole quadratic. You just want to get used to it. That would actually be a perfect square trinomial, right? And if I wanted to write it in factored form, I'd have x plus 13 over 2 squared. There you go. So now let's use this to actually solve equations. So we want to solve by completing the square, round to the nearest tenth if necessary. Okay, before we want to get our equation equal to 0. Well, in this case, if I get my equation equal to 0, if I would minus this 12 over, I wouldn't be able to complete the square because I want to get this part by itself, like the x squared plus bx, right? I want to get that by itself, okay? So we're going to kind of change things around this time. We just want to get the x squared plus 6x by itself so we can complete the square. So I got a minus 5 to get that over there. Now I have x squared plus 6x equals 7. Okay, we're not going to worry about that 7 for now. I just want to complete the square on this left side. So remember, I take half of b, which is 3, and I square it to get 9. So I need to add that onto the end of that. So I'm going to add 9 there. But if remember, to make sense mathematically, if I add something to one side, I have to add it to the other side to keep my equation balanced. I have to do it, otherwise it won't work mathematically. So I got x squared plus 6x plus 9 equals 16. You got to add that 9 to the other side. Don't forget to do that. Okay, that's an easy step to forget. Well, now I know it's a perfect square trinomial. So this will break up into x plus, remember you just take the square root of the first and last terms, x plus 3 squared equals 16. And then to solve, we want to get the x by itself, so I got to get rid of the square, so I got a square root, which means I square root the other side. So I got x plus 3 equals plus or minus 4. Don't forget that it's plus or minus now. And to finish it off, we subtract the 3 from both sides. And remember that you got to subtract 3 from 4 and negative 4. So x is going to equal 4 minus 3 and also negative 4 minus 3. So x would equal 1 and negative 7. Okay, I know it might be kind of confusing right now, but let's just try another one here. Let's try another one. So same thing. I want to get the x squared plus bx, that part by itself. And if I notice I have a coefficient on the x squared, I want to try to get rid of that as well. But first step is to get that minus 10 to the other side. So we want to add 10, left with negative, 2x plus 36x equals 34. Okay, I don't like that coefficient on my x squared, so let's factor it out of there. So I'm going to factor out a negative 2. So I'm going to pull a negative 2 out, x squared minus 18x equals 34. And let's bring it to the other side. So I'm going to divide by a negative 2. So those cancel, so we're left with x squared minus 18x equals negative 17. Okay, so let's go ahead and complete the square. Remember, I take half of b, and I square it. 89 squared. So we get 81. So I want to add that to both sides. Right, add that to both sides. So I get x squared minus 18x plus 81 equals 64. 64, I believe. 64. And now we want to use our perfect square trinomial. So this breaks up, this factors into an x. Now I got a minus sign right because of that. X minus 9, take the square root of the first and last terms, squared equals 64. I'm going to erase this stuff over here so I got some room to work with. So I'm going to write that up here. X minus 9 squared equals 64. Right? We squared up both sides. Square up both sides. Cancels there, so I'm left with x minus 9 equals, remember, plus or minus 8. And we add 9 to both sides. So don't forget that you're adding 9 to a positive 8 and a negative 8. So x would equal 17 and 1. X would equal 17 and 1. Okay, so just get your x squared plus bx by itself, complete the square, factor because it's a perfect square trinomial, and then go through and solve. Let's quickly look at this last situation here. I'm going to minus the 7 to both sides. So I got 2x squared, not a negative 2x. 2x squared minus 2x equals negative 2. Remember, I don't want that coefficient on my x term, so I'm going to factor out a 2 minus x and divide by 2. So I got x squared minus x equals negative 1. And then we take half of b, which is negative 1. So we hit half of b, and we square it. So I get 1/4, and I want to add that to both sides. So I end up with x squared minus x plus 1/4 equals negative 3/4. And we factor our perfect square trinomial. So I basically take the square root of the first and last terms, right? So I get x minus sign minus 1/2 squared equals negative 3/4. And we square up both sides, all right, to get rid of our square here. Uh-oh. Can I take the square root of a negative? If you try it on a calculator, I bet it doesn't like it. So in this case, it does not work. I can't square root a negative. So there are no solutions here. So basically what this is saying is, if I graph this, if I were to happen to graph this equation, it ends up falling, no, just kidding, above the x-axis. So there's no solutions, right? There's no roots. So there's no solution here because I cannot take the square root of a negative. So remember, to complete the square, you got to get everything out onto one side. So you have x squared plus bx on one side. So half of b, then square it, add that number to both sides, and then go ahead and factor and solve. That's all I got. Deuces.